Hello, so this is the second part of the video series on sequence and series. In the first part of the video, we look at sequence and we also look at arithmetic progression and geometric progression. So in this video, we are going to look at series. Now, series is just like sequence. The only difference is that we add the terms together. You know, in sequence, the terms are separated by commas, while in series, the terms are separated by the plus sign, the addition sign. In series, we are much more interested in the sum of all the terms. So the sum of nth term of the series. So we can also find the sum of the terms in the sequence as well, but we are much more interested in the sum in series. Now, in series, we add the terms together to find the total of the terms. So let's recall that the first term is denoted as A. The common difference D, the D is denoted as a common difference. And N is denoted as the number of terms is denoted as N. So a series can be written as A, and the first term A, the next term will be A plus D. This is the second term. You have to add, if it is an arithmetic progression in this case, AP, I'm looking at an AP, but written in form of a series. This is the first term, here's the second term. The third term will be A plus 2D. Then, this is what I'm doing. 2, let's say this is a series, 2, 5, 8. Now, this is a series. It's an arithmetic progression because it has a common difference of 3. Okay. If I want to write it as a sequence, I write it as 2, 5, 8, 11. Okay. Now that's what I'm looking at here. This is the second term. This is the addition sign that separates each term. Then there's A plus 3D plus. Now, if I continue, then I will get to the last term, L, the last term, which is in that sequence, the very last term in that sequence, in that series. If I denote it as L, remember that L is basically the nth term that we derived in the previous video, which is A plus n minus 1D. So that is that L. So now I have that. But if I want to get the element, the term just before the last term, is going to be L minus D just before the last term. And okay, let's say this is the last term here. Let me make this. And the element before the second to the last term will be L minus 2D. So that means if I subtract, if I want to go backwards, if I subtract 3 from 11, I get the one before it. So if I want to get the one before this one, I have to subtract twice the difference from 11. So that's 2 times 3, that's 6. If I subtract 6 from 11, I get 5. So that's what I'm doing here. This is L plus 2, L minus 2D, dot, dot, dot. So it means that this continues. So let me rewrite it here so that you understand what I'm doing. This is a sequence. A Then the next term, a plus d. The next one, a plus 2d. Then a plus 3d plus L minus 2d, L minus d, L. Okay. So if I want to find the sum, that is, if I add them up, what do I get? If I add all these terms here, all these terms in the series together, I can write the sum of the nth term, the sum of all the terms in the series, denoted as Sn. I can write it as a plus d plus a plus 2d plus a plus 3d. So it's just like what I've written before. That's simply because a series is separated by addition sign. So L minus 2d plus L minus d plus L. So this is the sum when I add all the terms together. So for example, here, here's what I'm doing. The S here, let's say S3, I will do 2 plus 5 plus 8. So just adding the first three terms. Now, if I write this sum, Sn, if I write it from the back, if I write it from the back, exactly the same thing, but I want to start from the back. I will have L plus L minus D plus L minus 2D plus dot 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 plus A plus 3D plus A plus 2D plus A plus D plus A. Okay, so if I add them together, if I add each of these terms together, so let's say if I call this equation 1, I can call this equation 2. If I add equation 1 and 2, then I will have 2Sn equals A plus L. That will give me A plus L. If I add A plus D plus L minus D, that will give me A plus L as well. How? A plus D plus L minus D. So this will cancel this, then we have A plus L. So if I add A plus 2D and L minus 2D, that will give me A plus L as well. A plus L, A plus L, A plus L. So that's how it continues. Dot, 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 plus A plus L, plus A plus L, plus A plus L. So the number of A plus L that I'm going to have will be equal to the number of elements I have in the series. So which means I can say that I can write the right-hand side as n multiplied by A plus L. So which means it's just like I have 2, 2, 2, 2, 2. If I want to add them up, let's say I want to add them up. So I know that this total will be 2 multiplied by, how many do I have? 1, 2, 3, 4, 5. 2 multiplied by 5. That's what I'm doing here. So I want to add the same thing. I repeat the same thing. So if I want to add them up, I just need to pick one and multiply by how many I have. So that's what I'm doing here. So it means that Sn will be n over 2 into A plus L. So this is the formula that you will use to determine the sum of nth term of a series. This formula also applies to a sequence as well, if you are interested in the sum of the terms. Now, but you use this when you have the first term. I'm sorry, when you have the last term. When you have the last term. So sometimes you're given the last term in that sequence or in that series. If you know it, good, this is easy. Because you can see that it's easy because this is just an average of the first and the last term. So average is A plus L over 2. You find the average, then you multiply by n. That gives you the sum. That's quite straightforward and handy. But sometimes we don't know the last term. So what do? You have two options. It's either when you use the second formula, because in the textbook, you might see this formula, which I'm going to derive in a minute, or you first determine L. Remember, we know the formula for L. You first calculate L, then you put that here. So what I want to do now is to derive another formula where I'm going to replace L with this. So that will look like I will look at the formula you've seen in some of the textbooks. Then Sn will be n over 2 into A plus, instead of writing L, because I know that L is A plus n minus 1 D. I'll just put A plus n minus 1 D. So Sn will be n over 2 into 2A plus n minus 1 D. So this is the formula. This is another formula you can use to find the sum of n stem of a sequence or a series. You use this formula if you know the first term, the common difference, and the number of terms in the series. But if you don't know, but if you know the last term from the question directly, then, and you know the number of elements in that sequence of the series, you can use the previous one. Okay. And that's the sum of n term of a series. If you have an arithmetic progression. If you have a geometric progression, you know, for a GP, we've shown that the nth term of a GP, Un, is AR raised by n minus 1 in the previous video. So which means if I want to find the sum, I can write the sum Sn as the first term plus the second term. You know, the second term has to be AR. We multiply the first by the second. We multiply the first by R, you get the second. And if you want to get the third, you multiply the second by R, that's AR squared. So you keep doing that, add them up to AR is to the power n minus 1. Okay? So this is Sn. If I call this equation 1, if I multiply equation 1 by R, multiply equation 1 by R, then I will get R Sn equals, so this becomes AR, this becomes AR squared, this becomes AR raised to the power 3 plus dot dot AR raised to the power n, because n R raised to the power n minus 1 multiplied by R, so this is raised to the power 1, you know, indices, you add 1, you add the power, so this cancels this, then you have R raised to the power n, that's why. So then if I call this equation 2, what do I do now? If I subtract equation 2 from 1, if I subtract equation 2 from 1, so equation 2 from 1, then I'll have Sn minus R Sn equals, so, you know, if I subtract 2 from 1, then this AR, we cancel this AR. This AR squared, we cancel this AR squared. This AR cubed, we cancel the next AR cubed that will be here. So that will continue. So what you're going to have left will be A, because there's nothing to cancel this A, and AR raised to power n, because there's nothing to cancel the AR raised to power n. So that means you have, but it's going to be minus because you're subtracting this, you're subtracting this from this, so it will be minus. At the end of the day, you have A minus AR raised to power n. Okay, so from here, if you factorize Sn, you will have Sn into 1 minus r equals, I can factorize a 1 minus r raised to the power n. So we divide both sides by 1 minus r, then you have Sn equals a into 1 minus r raised to the power n divided by 1 minus r. So this is the formula for finding the sum of nth term of a sequence or a series. So we use this formula when it's advisable to use this formula when r is less than 1. It's advisable to use this formula when r is less than 1, because you don't yes, it's easier when r is less than 1. Otherwise you have a negative value here, and even if it is not less than 1, if you have a negative value here, then they should cancel out anyway. But if you have r greater than 1, you can use this formula. You can use that r raised to the power n minus 1 over r minus 1. So r greater than 1. Okay. So that's it for this video, and I will see you in the next video. Bye bye.